I'm just going to recap through all the chapters in Form 1 Maths. So chapter 1 is rational numbers. Okay. So rational numbers is a very, very basic, very, very simple chapter. Yeah, so I won't want to dwell too long on it. The more important things about this chapter, okay, number line, I believe you should know how to draw your number line. Yeah, when I have an arrow to the right, means I'm going larger. To the left side is going smaller. Your plus minus, even if you have trouble doing manually, you can always use your calculator. Okay, but I don't recommend over relying on your calculator lah. But of course, in exams, if you don't know how to count, or actually always use calculator lah. Yeah. Even if you can count manually, maybe after you count manually, just use your calculator to double check. Okay, because sometimes you may do careless mistakes and all that. Okay, so plus minus of your integers, I won't really want to go through too much. Times, divide also. Yeah, you should know. Okay, just remember, same sign plus, different sign minus. Okay, same goes for times, divide. Same sign, answer will be a positive value. Different sign, answer will be a negative value. Okay, that you see this one, positive, negative, this one answer negative. Negative, negative, answer positive. Okay. Then make sure you know your board mass. Okay, your calculator will actually calculate in board mass order lah. But sometimes you may need to show working, or it may be a guided question where you need to like fill in the blanks. Then you still need to know which one you have to do first lah, instead of relying too much on calculator. Okay, make sure you know bracket first, anything inside the bracket. Then order is the power. Okay, power has to happen first, then your division, multiplication, add and subtract. Yeah. So if it's inside a fraction, it's like having a bracket on top and below. Okay, so you have to do what's on top first and do what's below first, then only you divide. Because fraction is just like having brackets. Yeah, another thing you need to know, actually one of the major parts of this chapter, of the chapter 1, is the laws of arithmetic operations. Okay, so commutative law again is you can switch for plus and times, you can switch the order of numbers. Yeah, means 5 times -2 and -2 times 5 is same. Plus also, this plus this plus this is exactly the same thing. Okay. Yeah, associative law means I can do these two first, or I can do these two first if it's just plus and times. Yeah. Okay, whether I do times these two or I times these two first, it's the same. That is associative law. For distributive law, basically I separate out. Like 102, I separate into 100 plus 2. So when I times, I can times separately. 7 times 100 and the 7 times the 2. Yeah, then I plus together. Like that. Then I get 700 plus 14. 714. This makes it easier to count when you do it manually. Of course, if I use calculator and count, then it doesn't really matter. But this is efficient calculation when we don't have a calculator. We're gonna just calculate in our minds. Yeah, these are the laws to use. Identity law is just like all the special multiplication, division, plus, minus, and all. Yeah, like when you plus negative of the same number, it's 0. Or when you times 1 over the same number, is 1. If you times 0, anything is 0. If you times 1, it still remains as the number. So these are the identity laws. Yeah, so these are example of how we do it. Like this one. Instead of plus 9 first, I can change the position of these 2 or change the position of these 2, doesn't really matter. So you see, I change the position using commutative law, because plus the order doesn't matter. Then associative law, I can do these 2 first. Yeah, instead of the front 2. Then identity law, plus the negative of the same number, it becomes 0. Yeah, then I straight away get 9. So by counting these 2 first, it makes it easier to plus. Because yeah, these 2 will just become 0. Okay. Or if I have 698, if I just count 698 times 11, might be a bit hard. But if I separate 698 to 700 minus 2, then use distributive law, 11 times 700, 11 times 2, it's much easier to count. Yeah, then I just take 7,700 minus 22, 7678. Okay, you don't have to really copy all this. I'll send to you the notes. Okay. For all the practice questions, if you want to try, you can try that, but optional. Yeah, it's optional. Yeah, calculation with fractions, make sure you know how to count. Your plus, minus, times, divide for your fractions. For the plus, minus, make sure you change it to the same denominator. Number at the bottom has to be the same, only I can combine them. Times, divide, just change to improper fraction. Then if we can cut, then we cut. Other than that, it's just top times top, bottom times bottom. Not likely they will ask you this. Yeah. Yeah. Plus, minus, times, divide in just fractions. Not so likely they will need you to show working lah. Okay. So don't worry too much about this one. Yeah, because counting all this, you can actually count using calculator lah. calculation of decimals also nothing much. Yeah, rational and irrational number. So remember, rational numbers are numbers that you can put in a fraction form, where the top and bottom are whole numbers. Yeah. Okay. So, which ones here? Yeah, we see all this. So, like number itself will definitely be a rational number. Okay. When I have decimal like that, it's also rational. Fraction like that is also rational. Yeah. Square root of 5. Do you think square root of 5 is rational or irrational? Do you think square root of 5 is a rational or irrational number? Square root of 5 is irrational. It's not a rational number. Because if I use say calculator, square root of 5. See, it's a never-ending decimal that I can never put into fraction form, where top and bottom are whole numbers. Okay. 2 pi, anything involving pi is also irrational number, because pi itself is irrational number. Yeah. Okay, if you key in pi, see, it's a never-ending decimal. It will keep going on and on. Your calculator only shows so many digits, but actually it keeps going on and on. Yeah, that's an infinite number of decimals. That's why you cannot simplify it into a fraction. Yeah. Okay. Is 4 cubed rational or not? Yeah, 4 cubed is rational. How about 2 3/7? Your mixed number is also rational. Yeah. Because it's basically a fraction. I can put in improper fraction, then it's 17/7. Yeah. How about cube root of 4? Is cube root of 4 rational or irrational? Yeah, cube root of 4 is irrational. Yeah. If you try to count cube root 4, it'll be a never-ending decimal. How about 2/pi? Irrational also. You involve pi times divide by pi, even plus pi, it will definitely be irrational. How about this 1.333 keeps going on and on? This is actually rational. See, 1.333 like that is actually 4/3. 4 divided by 3 is your 1.3333, where the 3 repeats. So a repeating decimal, if it keeps repeating the same decimal, is still a rational number, because it's still a number that I can put in fraction form. Okay. Yeah, so the only ones that are irrational are those that involve your roots, basically, and also your pi. Other than that, yeah, they are all rational numbers. Okay. Yeah, all these normal calculations shouldn't be an issue lah. Of course, make sure you know how to key in into your calculator lah. So although they say without the use of calculator, actually you still can use calculator. You just need to show working. So usually the working is you need to show your board mass, which one you do first and what you get when you count that part. Yeah. Okay, that's for the Form 1 Chapter 1. Then